Hey everyone, so welcome back to the channel. I hope you all are doing well and fine. In the last video, we covered our topic, which was the exception handling. And in this video, we will be starting with our new topic, the very important topic, which is the object-oriented programming. In this video, we will be studying what are the classes and the objects and how you can create these and what are the real life implementations and the operations you can perform on the same. So without any further delay, we will start our today's content. So let's get started. So starting with the classes, what is a class at the first place? Class is like a blueprint. If you want to create a car, we will understand it with an example. Like if you want to create a car, can you directly just create a car by yourself? No, you don't. You cannot do it like that. You will first need a design. Like a car has a four tire, a gate, an engine, windows, and how these will be aligned. How you can design it. Like you first want a design of the car. So that design that defines how you can create the car. Oh, I'm sorry. That design it is what known as a class. So it's like a blueprint of any real world entity. So a class is a blueprint for creating the objects. Here we have created a class which is its name is dog. So uh, see, it is a blueprint of a class which name is dog. Like class is not a real world entity, it doesn't exist in real world, it's just a blueprint. And here we have created dog Rex. It's the name of the dog. So here the Rex is a real world entity, it exists in the real life. So this one is known as the object is an instant of a class, and it has a meaning in the real life as well. Like in the cars we have the example, like the design, it doesn't exist in real life, it don't have the meaning in the real life. But yeah, the cars we have created using the design, like the BMW, the Rolls Royce, Lamborghini, and so on, these are what the objects which are created using those blueprints. So object is an instance which is created from the blueprint or created from the class. So I hope that is clear to you. That's the basic definition and the most basic way I can explain to you. And yeah, here we have another analogy. A class is a cookie cutter shape, like the shape of a cookie cutter, it is a class. And the actual cookie you will cut from that cookie cutter, it is what? A object. Like it is in real world entity. So I hope this is clear to you, the class and the object. We will see the practical implementation as well, like how you can create a class. Here we have given it in example already. So you will write the class, then the dog is the name of the class, and using the same you can create a multiple objects. Like with the help of a single class, multiple objects can be created. Like several objects can have the same design, like the identity can be the same, blueprint can be the same, but the entity, it will be different. So multiple entities can be created using a single class. So now we will be creating our very first class. Let it be class student. Why do we have the need to create the classes at the first place? Classes somehow helps you organize your data. Like there will be several students present in a class, and you want to arrange the information of the students, like the name, the age, section, and all. You can create the class, and you can create the objects of the same class. And in the multiple you can create the multiple objects for each student, and you can organize the information of each student in a particular object. So this is a basic or the very important advantage or the requirement of the classes and the object. So Firstly, we have created our first class, which is the student. And do remember, whenever you will be creating a class, the name of the class is always be starting with a capital letter. Why? Because it's not like any hard or fast rule. Like if you won't write it in the capital letter, you will get some sort of error. It's not like that. It's completely up to you. But for the good coding, like the convention, by the convention, its first letter it should be in capital. It shows the good coding practice as well. So yeah, it's up to you, it's your choice. If you don't want to write it like that, you can create the class with the small letter as well. It's up to you. Then we wrote another keyword, which is pass, which shows that our class, which class we have created right now, it is empty. It doesn't contain any sort of data inside that. So I hope this is clear to you. Then our class is created. We can create the objects like s1 equals to student. Wait. So yeah, our first class is created. You can create the multiple classes like how much you want. It's up to you. Second class is created. But right now, if you will print your class S1, it will not give you anything. Why? Because right now the class, the object, it doesn't have any value. Why? Because you have created an empty class. It doesn't contain any sort of value inside that. If you will execute this, see, it's just it is an object, like it is written, it is an object, s1 is an object at this location and inside this class. So I hope this is clear. And now we will see some attributes or the functions which you can, methods you can perform using the classes. So now we will see the attributes in our classes. So what is an attribute at the first place? Attribute is any information about your what object. Like the first object we have the s1. So any information about the student s1, like the name s1 dot name, let it be Rahul, is an attribute. Second, s1 dot age is another attribute. So attribute is nothing, just an information about your object. Like in same way you can create the attribute for s2 as well. s2 dot name is equals to, let it be Dia, and s2 dot age is equals to 22. So here now we have created our attributes with the objects as well. Like, and now if you want to print the name of the student s1, you will have to write s1 dot name, and your Rahul will be printed, and s2 dot name, then Divya will be printed. And see here, Rahul and Diya is printed. And yeah, if you can see, the problem in this code is whenever you will be having the multiple objects, like we have two objects only, so we have created the name for two objects, the name or the age for two objects, we have created the attributes. But in case of, like, we have a class of students, like 70 students or 40 students or many students like that, you cannot manually create the classes, the attributes one by one. So in that case, the constructor comes in the view. We will see that as well. First we will see the methods we have in the classes. Always remember, whenever you define a method, it always starts with the keyword def study, and here self. And in this we will print studying. So here our method is a is just like a function like we have created earlier in the functions. It will perform some sort of operation, like it is performing some sort of function, like it is printing studying. So it is your a method. And if you want to print that, you will print, no, first you will create the class. It's like you're calling a, like we have studied the calling in the function. It's like it's the same way to print that, print the whatever the output of the method is. You will call the function, or you will create the create the object of the class. It's like the calling only. So here we will create s1 equals to student, and we will print s1, and we will see the output. Wait, okay, now we will see the execution and see studying. Here in your method, the output is studying, so studying is printed. I hope this is clear to you. Then yeah, the next we will be starting with our constructor. Now we will be starting with the constructor. So always remember, why do we need the constructor at the first place? Constructor will automatically runs the code, like whenever you'll be creating a object, it will automatically start the execution by itself. Like always remember, the name of the constructor is double underscore init and double underscore. And one more thing to remember is, whenever you will be writing the constructor, the parameter you will be giving to the parenthesis, it will always be self. Self defines that it will make sure that Python interpreter will consider the object to be the current object. Like self dot name, we will write, and let the name be Rahul, and self dot age equals to 21. And then we will create a class s1 is equals to student, and we will print s1. Like we have called the this class, we have called this class. Wait, s1 dot name. And see, here we didn't even specify the name or anything, and we will print this. And our s1 student already got the name Rahul. So if you don't even initialize the name by yourself, the by default name given to the constructor, it will be initialized as your the name of the first class. Even if you want with multiple classes as well, you can do the same with the help of constructors only. So now we will use the constructor for creating multiple classes as well. Like but for the same, you will have to give the number of attributes, the name of the attributes which you will be creating. The first one will be the name, second will be age, and now we will write the syntax, which is name is equals to name, and again age is equals to age. And now in here, like when you'll be creating the classes and you will be calling the function, calling the class, you will give the input like Rahul. For the first object, I'm giving Rahul 21. Same way, you will create a second object, student, with the same class again, Diya, age let it be 22. Same way for third student, Riya, age is 20. Now if you will print s1 dot name, your Rahul will be printed, and same way s2 dot name, your Diya will be printed, and s3 dot name. And we will execute this code and see Rahul, Diya, Riya is printed. So this is how your constructor works. And then you will be having a doubt, what is this self? See, self is it's not a keyword or anything. It's like it tells Python interpreter to initialize the initialize or to point at the current object, like not pointing, but it will make the Python interpreter aware of the current object. It means the current object, like if you're writing this s1 dot name, your interpreter will think what the name, it is equals to Rahul. So at this place, the self's value, the value of self will be what? Rahul. Same way here, now your Python interpreter will be thinking, like for now it was thinking Rahul is the self dot name Rahul, and then second way, your self in that self word, it's not a keyword again, it will make Python interpreter think that the value of this one s2 dot name is Diya. From here it will be making the interpreter familiar the s2 dot name's value is Diya, the current object is Diya, and same way the s3 dot name, the current object is Riya. So this is the function of your self operator. I would say it's not a keyword that I would remind you again and again. Many students do get confused in this thing, that self is not a keyword, yet it has a specific meaning. You cannot use it as an identifier or anywhere else, but yeah, it's not a keyword. And again, one more thing, you can also take the user input to display your output. Like here we have given the input as Rahul and 21 by ourselves, but if we want to take the user input, you can do that as well. Input, enter name, and age is equals to int, input, enter age. And here, instead of writing Rahul and 21, we will write name and age, and we will get to take the user input. Wait, see, Anushka, age 19, and see, here we got again age is equals to Anushka, name is Anushka. And see, again the s1, you can change the name as well. Multiple times you will be giving the multiple input, it will give you the output the same way. So by now you have seen all the basic operations or the basic concepts which are used in the classes. So now we will see one final program, the final program to cover this topic. Then we will be starting with the properties of the classes. Now we have created our constructor. Let there be one more parameter or the attribute course, and here we will give one more create one more attribute course equals to course, and we will create another method to print all these all the values. display print name self dot name. Self now defines the current object or the current value your object is holding. Then we have age, self dot age. Then lastly we have the course, self dot course. And now we will create our class S1 is equals to student and we will give the user input. We will give the input by ourselves, Rahul 21, and S2 is equals to student Diya 22 CSE. And here also we will give the course, let it be BCA. And now we will call our call our objects. Wait, there is some error. Yeah, we forgot to write the self in our as our parameter. And see, here we got the output like this. So I hope this is clear to you. This is the most basic program you can have of the class and the objects. And then we have the properties or the functions which you can perform on the classes. We will see those one by one: the inheritance, polymorphism, encapsulation and abstraction. So I hope this is clear to you. So now we will be seeing our new topic, which is the inheritance, and which is one of the pillars of our OOPS programming. So what is the inheritance at the first place? See, normally what you mean by inheritance is like something you receive from your parents or from your parents or grandparents, like the elders. So, like an example, like your parents are having a house, like they have built the house, it's their house and you are also living in it, like, so you got that house from your parents. So in the same way, in the OOPS programming, there is a parent class and there is another class which is known as the child class, and the properties that child class it inherits from the parent class, this process is known as the inheritance. So we will see one example, like we will create a class of animal and we will define some methods in it, like animals eat and print animal is eating. We will create one more method, let it be sleep, and we will print the same, animal is sleeping. So this is it. Now we have created our one class and this class is known as our parent class. Then second, we will be creating our child class, let it be any animal like dog, and the class it is inheriting is animal. and we will create one function, sound. And we'll print dog is barking. So now we have created our two classes. See, one is this parent class and second is our child class. And always remember, whenever you will be writing your child class, you will have to specify the parent class it is inheriting. So now we will create an object, let it be S, and dog. And now we will call the methods in the parent class as well and the child class as well. Eat, s dot sleep, and s dot sound. And we will execute this code. And here we got our output. See, we didn't have to write these two methods again and again. Like if you are trying to write for like in the case of students as well, like a student is talking, is studying, like if you want to write it like that, you will have to like create multiple classes for each student and then multiple objects for the same. Like yeah, I'll consider object it is necessary you will have to create for each entity, but like for the classes there is one class that is sufficient for us. So yeah, with the help of this your code's usability increases. So it is one of the most important advantage of the inheritance. It helps you save your time writing the whole messy code again and again, and instead you can just directly inherit the properties from one class to the another class. So I hope this is clear to you. Then the next topic we will be having is the polymorphism. And what do you mean by polymorphism? Like if you break this word, poly means many and morphism means forms. So it is like a class that is having multiple forms. So we will see that also with a practical example. So now, as for the polymorphism, I will first try to explain you it with an example. Like consider a word sound, and like you will see like in your class also, teacher teaches, children talks, or the singer sings, like this. Everyone is performing the same thing, like they're speaking, but the style of their speaking or their sounding is different. So here sound is a thing which is same, but for different like species or the entities like teachers or the students or for the singers, the form is different. So like the one word, the speak or the sing, the same word it is having different forms for different entities. So this is an example of polymorphism. You can also take it an example of a of start. Like if you're starting a car, your engine will start. If you're using a washing machine, your machine will start. Like it will start the washing thing. So yeah, thing is start, but the form is different. Like for the cars, it is different. For washing machine, it is different. So this is the example of polymorphism. We will see it with an coding example also. Like we will create a class of let it be a dog, and the method inside it let it be sound. Self, we will print here the classes of dog. So dog barks. Then next class we will create of a cat, and again the method will be same, sound, and we will print cat meows. And now if we will create an object like the multiple objects in ones. Dog and cat. For A in animals, print A. I hope this is understandable to you. It's not confusing. Like you know the for loop now and the list. Like we have created a list of the, instead of just creating the single objects one by one, we have created a list, and inside that list we have iterated our variable A, or you can say the iterative element, and we have printed the iterative element. So we will execute this code. Okay, wait, there is an error. Okay, so yeah, instead of printing the iterative element, we will print our method, which is a.sound, and then we will execute this code. And here the dog, it barks, cat meows. So I think it is clear कि your same thing, the sound, it differs for all the animals. Like for the cow it moves, or other, for other animals like it's different. So the word is same, the thing is same, the sound is same, but yeah, for different species, for different entities, it is having what, a different form. So this is what known as the polymorphism, and this is an example of method overriding. Like in case of function method overloading, there will be multiple parameter. Like here we gave just one parameter, but like for the next method, or for the next method, there will be methods of the parameters more than one. Like there will be different parameters. It accepts multiple parameters. It's only difference in the function method overloading and overriding. And yeah, in your Python, for the current version, the modern version, method overloading is not applicable, and you can only perform the method overriding, and it is an example of method overriding only. So I hope this is clear. Our next pillar, the third pillar, is encapsulation, and lastly we have the abstraction. So I hope this much is clear. We will move forward to the encapsulation topic. So now we have the topic encapsulation. So first of all, what is the meaning of encapsulation here? It's like wrapping all your classes or the object, no, not all the classes, like the objects or the methods or variable data, everything you have in a class, into a particular unit or into a single class. You can take an example like of a bank account. Like you are having a particular bank account, you can check your balance, you can withdraw, you can deposit, but you cannot directly set your amount to be how much you want it to be, like that. You will have to go through some the rules and regulations. Like in your bank account, if you have 1,000 rupees, you cannot withdraw out the 2,000. It's an example of encapsulation. So your data in encapsulation, it is hidden or private. You cannot directly access your data. You have to go through some rules and regulations. So in that case, encapsulation is helpful. You can now we will see an example. Like we will create a class bank account, and we will create we can create the methods. First, to check the balance, and self, and let your balance be 1,000. And then we will create a next next method, that is deposit. That means you will deposit some amount. Self amount, it's the amount you will be depositing in your account. So now your balance will be added up with the amount. So this is your amount now, and then we will withdraw the money from your account. withdraw, again self amount. Now first of all it will check whether the amount is smaller than your balance. Print invalid amount. Self.balance, and now else balance minus equals to amount. So I hope this is clear. Now we will execute this code. And we will deposit s dot deposit, let the amount be 2000, and s dot withdraw, let it be 1000. And we will execute this code. Here it is giving us an error. Okay, wait, we will see what's wrong with our code. Okay, so now here we forgot to create our constructor in it, double underscore. Now we have created our self.balance, and we will check the amount at the end. Check balance. Print see here I'm using this double underscore. Why? Because that means your variable, whatever the value it is storing, it is extremely private. You cannot directly access that variable. And in the end we will check the balance. I hope this is correct now. No. Okay, again. Okay, so yeah, here also you will have to use the double underscore. If you don't use the double underscore, it will give you the error. Why? Because you are using the encapsulation, and if you will directly just write it like without the protection, it will give you the error. Like all over here we have used the our balance with the double underscore to make Python interpreter aware that this variable is extremely private. You cannot directly access that. Now our code is correct. See here, invalid amount. If the amount is less than the balance, see, and here we have added the deposit amount to be what? 2000, and our origin, no, sorry. Okay, I will add one more zero. It's 10,000 now, and we will execute. Invalid amount still. So we will remove this line, and instead we will just use the okay like this, and see our current balance is 11,000. How? Since in the first starting we have 10,000 in our account, and then we added 2,000 to it, and again here we withdraw 1000, so now it is 11,000. Now if you will try to withdraw the amount more than in your account, we will see what will happen. See, it is giving you a negative, which is not possible. So for that case we used that if statement, but there was some error in that, so I will check it again and we will move further to the last topic, which is the abstraction, and we will see what's the error in that. If amount is greater self dot balance and invalid amount. Else invalid amount. Okay, so maybe there was some sort of syntax error. Now it's working, you can see. Since we have added withdraw 1000 from our account, first of all we had 10,000 in our account, then we added 2,000 more, so it was 12,000, and then we withdraw 1,000 from that, so now our balance is 11,000. So here the current balance is 11,000, and if you try to you can like withdraw the amount more than the amount present in your account, it will give you the invalid amount, and the current balance is 12,000. So you cannot withdraw the amount which is more than the amount which is more in your account. So I hope encapsulation is now clear to you. The last topic now we have is the abstraction, and the meaning of abstraction is that it will show you only the relevant details and hiding the unnecessary informations. So we will see with an example and a programming code as well. So I hope this much is clear. Now the abstraction, like I gave you the basic idea of abstraction, that abstraction means like hiding the unnecessary detail and instead showing only the relevant one. Like you can take an example of a car, like you're driving a car, what do you need to know? You need to just turn the key or press the button, you have to press the gas, or then you need to turn the steering wheel. That much you need to know how to drive a car. Instead, like you don't have to know about what's going on inside the engine, how your fuel injection working, how the gear machine is working, you don't need to know that, so it's not visible to you. So this is an example of what abstraction. Like you can also have another example like of a coffee machine, like you will have to boil the water, you will have to grind the beans, and you will take out the coffee which is made by it. You don't need to know how the water is boiling inside the machine, or how the beans are grinding inside the machine. So this is what an example of abstraction. So we will understand this by a small code. So now we will see a basic code which is of coffee machine. And we will create some internal functions, let it be coffee self, and then we will create some methods like self dot boiling water, then self dot grind beans, and the last step is mixing, so mix, and in the end we will print your coffee is ready. Now you can see we have created three functions, the three methods, and inside these methods your step-by-step preparation of coffee will be taking place, like def, boiling water, and we'll print water is boiling. The next method we have is grind beans. We'll print grinding the beans. And last we have the mix and print mixing, just mixing. And now we will create a class of coffee machine, and we will call this one method only, which is the coffee. And instead of calling all the methods like these methods, these are the information which we don't need to know, like it will you can add the step-by-step procedure or whatever, like your water is boiling, you need to know, your beans are grinding, you need to know, and your mixing is taking place. But how these things are taking place, you don't need to know that. So only the information which is this and this, it will be printed. We will execute this code. Okay, again there is some error. Yeah, I forgot to use the double underscore here, which is of course giving us an error. So and see, from here we will comment all those out. Now we will execute our code and see, water is boiling, grinding the beans, mixing, and your coffee is ready. This much we need to know. We don't need to know how and like how it is working, how the things are working inside the machine. We only want to know the steps which are taking place: water boiling, then grinding the beans, then mixing, and in the end your coffee is ready. So this is how your abstraction works. The only difference between the encapsulation and abstraction is abstraction hides the information like which you don't need to know, whereas in the encapsulation your data is wrapped or it is protected, or like encapsulation is protecting your data and abstraction is hiding the unnecessary details. So this much for the video. So I hope this topic is clear to you. So that was all for this Python series, and I hope everything is clear to you, and in case of any doubt you can drop out the comments, and see you next time.